Okay, this lesson is on what's called experimental probability. Up until now, we've been looking at situations, listing all the possible things that can happen, and recording what outcomes there could be. As we do that, we've always made the assumption that each outcome is equally likely, or each section is equally likely. The only way we've had probabilities changing is when, say on a dice, two sides were labelled the same number. That's allowed us to get slightly different probabilities. In the real world, problems are either too complicated to analyse, or we can't actually see how the effects interplay to be able to decide on the chances of something happening. Sorts of things we're talking about are things like if you were to knock toast off the table and onto the floor, is it as likely to fall jam side down or jam side up? It's one of those things where you could think of lots of reasons, sorts of things, interplay of chances, and you'll probably not be able to come up with a clear answer. What you do is you would probably go away and you would make maybe 50 pieces of toast, all jammed, and check, okay, did it land jam down or jam up? And as you go through, you tally it up, and maybe towards, say, you do a tally table in between, and then you'd record the total frequency at the end. And this down, maybe it comes up as down came up, jam down came up 28 times, and up came 22 times. Now we can use this to calculate what's called relative frequency, and that's just a ratio, a fraction of the times it came up. So our actual answer would be 28 out of 50 is the frequency that it landed down, 22 out of 50 it lands face up. And you can calculate those as decimals, and if you put them into a calculator, you get 0.56 and 0.44. Okay, see, I don't know why I didn't put the CY on the end. Okay, so you could actually consider that situation. This relative frequency, this number on the end, is actually a form of probability. This is probability of toast being down, and we use those probabilities to be able to make predictions. I think I'll avoid that light bulb one now. It'll take the video too long. So the probability of it being down is 0.56. So if I set the probability of it down as 0.56, what would you expect if I did 100 of those? Well, in this case, it's the 28 out of 50, and we're going to try and change that into something out of 100. Well, what am I doing? I am going to take the 28, divide by 50, and multiply by 100 to give me my number of values. And this can be written as something saying expectation of down is your probability. That's the 28 over 50. Divided and multiplied by the number of trials. Calculate that value, and it comes out as 56. So my pen stopped working now. So if I was to try the jam experiment, when I try it 25 times, I would expect down from 25 attempts to be my probability, 0.56, the relative frequency, and multiply it by 25. take your calculator and type it in. Just wait for my calculator to come up. 0.56 times 25. I get 14. Now, it's important to understand the idea of expect. If I did it 25 times, I might find that I actually got 12. Well, are we going to say that that means that our probability is wrong or something different's happening? Well, 12 is quite close to my expectation. I don't expect it to always give me 14, but something about there. If I actually got something like along the lines of 3 landed down, I would say that means that my idea about probability of Jan landing face down is wrong. So 3, that would say my hypothesis, my idea, is probably wrong. So if I was to ask you all to throw a coin, toss a coin 100 times, you would expect coin toss about half of those trials to come up as being heads. So I'd get probably 50 is what you would expect. If I got the whole class all giving me 50s though, I'd probably be telling you to go away and do it again. Because if I got lots of 50s, I know that the probability of getting 50 in this case is, I know the probability of getting 50 heads from the coin toss is only about 10% of the time. So more than 3 or 4 of you say, 2 or 3 of you in the class saying, I got 50, I would know that some people have been cheating and just saying what their expectation was. And there are mathematics for doing it. You don't need to worry about that. But what you do need to be able to do is take these numbers and calculate an expectation and a probability. Now I'm going to do a question with you that comes from the same exercises that you'll be doing. These are old SAT questions. And I'll go through it with you so you see the sorts of things that you will get asked in an exam question. So a dice with 4 faces has 1 blue, 1 green, 1 red, 1 yellow. Now initially you might think, oh, the probability of them is going to be equal, so the probability would be a quarter, a quarter, a quarter, a quarter. That would be the case if it was fair. Now these pupils are going to find out if they think this dice is fair. So 5 pupils do the experiment to investigate whether or not the dice is biased or not. So each of them sat down with the dice and rolled it. And they got the following information. Peter did 20 tries, and he got 9722. Carol, 60 tries, 23, 28, 9. Shana, she did 250, she got 85, 90, 36, 39. And you see the other numbers. Now, to get the best answer for this, you need to have as much experience as possible. So which pupil's data is most likely to give the best estimate for each colour? And it would be, in this case, the person who's got the greatest experience of the problem. Greatest experience of the problem is Shana. She's done 250 experiments, far more than anybody else. So Shana has done more experiments. So she's most likely to be the best answer. So she's likely to give a good answer. If she did everything fairly. So pupils are collecting all the data together. So this is now everybody's data has been collected together. We've got 400, 500, 520 throws. And we're going to analyse based upon this table of frequencies. Have a look at the situation. Do you think that this dice is biased? Are the numbers about the same? Well, 75 and 80, you'd probably say, yeah, there's an even chance that you get either of those. And 179 and 86, they've got an even chance. But these two pairings are massively different. And because of that, you're likely to say there is actually a bias in this. And bias says, when you say bias, towards which value? So I would say this is bias towards, we're going to get more reds and blues. Because there are more of them. From the data, work out the probability of the dice landing on a blue face. Now there's my blue face, and the probability is the probability of it being blue is calculate the relative frequency. So the actual frequency is 186 out of 520. Go to my calculator again. 186. Got to press the right on button. 186 divided by 520. Gives me a probability of 0.357. The 7 rounds up the next one, so 0.36. That means about 36% of the time, people often talk percentages with probability, we would get a blue, on average. We'd have to do it lots and lots of times, and the more times we do it, the closer we should get to that 36. Probability of landing on the green, you can go away, do the same calculation. The other thing I can do with this, though, is I can make a prediction, which is often an E-type question, estimate how many blues you should get for 1,000 tries. So my expectation of blue, this E bracket blue says expectation, would be my 0.36 multiplied by 1,000. And this is an estimate. So it's not an accurate answer, so I can use a wavy equals, and it says I am roughly around, do the calculation, and we get 360 blue. If I got something between 330 and 390, I'd probably accept those values. We could also check how good Shana was. If Shana's probability is about the same as that 36, she probably did reasonably good results, because it would agree with what everybody got overall. So let's just do Shana, divide by our 250. And she got 0.36 as well. So Shana probably did give me the best results because it agrees with everybody else across the whole lot. So I can actually check how good Shana was as well. Okay, I'm going to give you a question like this to do. The computer-based ones I found are not very good, so it will be a couple of questions like this. Please write them into your books, and as before, copy them and send them back to me either as attachments that you create yourself or put them into a document to attach. Okay.